Hello, welcome to Fascinate. My name is Kate and I'm a Brownie leader and work at RAL Space at the Science Technology Facilities Council, STFC, where I'm an environmental data scientist. Today I am also joined by Vicky, Hannah and Vivienne, who also work at STFC. So Vicky is a communication officer in RAL Space. Vivienne is a laser scientist who has a background in electronics and engineering, and Hannah is a mechanical engineer. So I'm going to pass over to Vicky now, who's going to just do an introduction to RAL Space.
Hello, everyone. Thank you very much, Kate, for having us today. And as she said, I work for RAL Space. We are the UK's national space laboratory, which sounds very exciting, but what do we actually do? So we help to build and test spacecraft. We've been involved in over 210 instruments that are on spacecraft over the last 50 or so years, and we're going to have lots more coming in the future as well. So we are based in Oxfordshire in England, and we work with lots of other teams as well. So the space industry is very collaborative. We often work with ESA, the European Space Agency, and NASA, who are based in America as well, that you've probably heard of. So what do? We are involved in almost all parts of different stages of a space mission. That can be at the very start, from thinking of new ideas for new missions. So if scientists have a question about how the universe works, or about climate change, or any different question like that, they think of a mission idea. Then we help to design the instrument. So what parts does the spacecraft actually need to be able to find out the answers to those questions? For example, do we need a camera to go on a telescope into space? And what type of camera? So we do some of the design work, and then we test everything. And this is very important, because once you've sent something into space, it's very difficult to do anything afterwards. And space missions are also quite expensive. So it's good to get things right first time. So we do lots of testing, and we have big facilities to put our spacecraft in, do lots of different tests. Then it's sent into space and we receive all the data back. So that could be images of Earth, satellites that are in orbit around Earth, looking back down, looking at the weather, looking at climate change, or it could be satellites looking towards the sun, finding out how the sun works. Or it could be spacecraft looking out into deep space, looking at galaxies and stars and planets. And we send all of this data back, and we can help store that on our supercomputer, Jasmine. And Jasmine has a lot more storage than our laptops and works a lot quicker than our laptops would do, so that scientists can access the data all around the world, and they can process it as well and find out the answers to the questions that they had at the start. So that's a bit about what we do. We have about 300 people working for us, lots of different types of jobs. So we'll all talk about what we do and what you could do in the future. So we have some work experience students, some school students can do some work experience with us. We also have apprenticeships, and we have university students as well, who work for us whilst they're at university or just after they finished university as well. So that's a little bit about what we do. One thing we don't do, interestingly, is actually launch things into space. So we do all the building at the start, and we do the bit afterwards once it's in space. So our challenge today is RAL Space are going to build a new satellite, and we want you to get it into space for us. How do we do that? Anyone got an idea? How are we going to actually put something into space? Any ideas? I'm going to say that we put it on a rocket. Rockets are very good at being launched from ground and actually having a payload inside or on top and taking it into space, going through the Earth's atmosphere right into space. And we can tailor them as well. So whether it needs to just go into Earth's orbit, for example, the International Space Station, or if it needs to go even further, if it needs to go to another planet, we first put it on a rocket to get it there for us. But how do we make a rocket? I don't know. Let's find out. So I'm going to hand back to Kate to tell us what materials we could use today to build a rocket.
Okay, so today for our rockets, we need a template that you can be able to download from the website. And this template does allow to have 3 rockets, but I've only got 2 on my sheet at the moment. You need a round pencil, some scissors, a straw with a bend if possible, and some sellotape. So our first step on our rocket making is we need to cut out this rectangle. One of the rectangles here is our first thing that we need to cut out. so that we can make the body of our rocket. And while we'll do this, let's just ask our engineers and scientists a quick question. So, hello, what currently are you working on? Or missions are you working on?
Shall I go first?
Yes, go on then, Vivienne.
Hi, so I'm Vivienne. I'm a high energy laser scientist. So I actually work at the UK's National Laser Facility. So I'm a neighbor of RAL Space. I do different stuff. I'm currently developing a diagnostic line, which basically just means testing or checking if all the parts of the laser system, well, not all, but some of the parts of the laser system are not damaged. So we want a very shiny working laser system. Yeah, so that's what I do here at the Central Laser Facility.
Oh, great. Very interesting. Okay, and we're still cutting out. Let's go quickly to Hannah then. What are you currently working on?
Hi, yes, I'm as Vicky described earlier, a placement student. So I'm working at RAL Space for a year during my university studies. Now I work in testing, so I work across all sorts of projects from both within RAL Space and outside companies as well. And we test all sorts of spacecraft and components ready for their launch on a big rocket.
Oh, very cool. Great. So hopefully now we should all have a rectangle cut out. And we now need our round pencil. So what we need to do is put our pencil on the paper and roll it quite tightly and secure it with some sellotape. So it might be easier if you do this on a table so you can get it quite as tight as you can. I have some tape behind me. And secure it with some sellotape.
Mine's slightly wonky. Is that okay?
Yes, that's fine.
We'll find out in a bit.
Yeah, so you should have it now. So your pencil should be still in there and secure.
Yeah.
Great. Okay. I'll just make sure Hannah's there. Don't want to lose anybody.
Got it.
Great. So what we can do now is take our pencil out. So we're left with a nice single tube, and at one end, so we're going to call this the top of our rocket, we need to make several slits around using our scissors, about 1 centimetre down, so that we can make our cone.
That's interesting. Why do we need a nose cone? Could I not just launch this as it is? What would happen?
Give it a go. What would happen?
I'm going to have a go.
Okay, have a go.
Have a go. So what I'm going to do is I'm going to put my launcher in. So that's my straw. I'm going to put this in and I'm going to blow through it. And that's how I'm going to launch it. But at the moment, it's just, there's a hole. There's nothing on the top.
No.
Have a think about what's going to happen. I'm not sure what's going to happen on this one. Because there's nothing for the air to push against. So I'm not sure this is going to go anywhere. Let's have a go.
It's sliding backward.
It's going the other way. No.
Yeah.
No. Okay. So it doesn't do anything. So definitely we need to make a nose cone, don't we?
Yeah. And we preferably don't need a hole in it as well, because a hole will also, if we have a hole in it, it will stop it from flying off. So
several slits, did you say?
Yeah, so you should hopefully have some slits at one end, about 1 centimetre down. I did about 7, but like 5 to 6 will be all right. And then what you're going to do is pinch them together and do a little twist and secure with tape, and make sure that there's no hole at the top. Again, I'm just going to reach behind me because I pre-cut my tape behind me.
Also worth mentioning, if you are using scissors, do just be careful, and adult supervision is preferred, is recommended.
Yes. So make it in a swirly thingy and then tape.
You might want to put your pencil back in just to help you make it into like a cone shape. But yeah, secure it up and make sure there's no hole. Oops, there's a hole in mine. We haven't quite secured that. I need some more tape.
There we go. Taped mine up nice and tight.
Very good.
I put a little bit of tape just straight over the top as well, just to get rid of any air holes.
That's what I've done, because I didn't manage to have a big hole. I missed the complete top of it. Great. Okay, so we've got, I'm taking my pencil out again. So now we've got our body for our rocket. We could have a go at flying it and seeing what would happen now.
Yeah.
And see what happens. So I'm going to put my straw in and give it a go and see what happens. I think I might have made mine too tight though. Oh no, it's just got in.
Let's do a countdown.
Okay.
3, 2,
1. Oh!
Hey!
Hey!
Mine just hit the monitor, so that's good.
Great. So we have a rocket, and what happened with our rockets when we blew them?
Mine hit
flew
a
somewhere.
monitor. Yeah.
Somewhere. So
Yeah.
it did fly, but we need to add something else to our rocket to make it stable as it goes up.
Yeah.
So if we need to send it to a specific place, we need it to be stable.
Yeah. So what do you think we should add to our rocket? I'm thinking we need some fins. Now,
Yeah, just like an aeroplane has.
yes, just like an airplane, like airplane has wings, we're going to do some fins for ours.
Yes.
So on our template, there was here 2 fins that we need to cut out. I'm going to cut these out, and while we do that, I'm going to ask another question. What does a typical day look like for both of you? Let's start with Hannah.
Okay, yes. So in the morning, I come into R100, our big building, and I say hello to Tim Peake. We have a cardboard cutout of him in our foyer. I say good morning to him every day. I come up to my little office where I am now and check through the testing that's going on that day. So we could perhaps be doing some shock testing, which will prepare a spacecraft or its component for when it goes up on a rocket and the different parts of the rocket break off at different points during its journey up to space. So we have to check that any shock that a spacecraft will feel at those points won't break it and that it will survive the journey to space. So we have a big machine that acts just like a big gun, and it fires a bullet and hits the test object very hard and very suddenly. So we just have to hope that nothing will break, or the engineers that are visiting us that day, bringing their spacecraft, will have to go away and build a better one that doesn't and can survive the shock and won't get damaged.
Oh, very interesting. Why does a rocket parts come up away in space?
Well, the big rocket that you see go up to space from NASA or the European Space Agency, it's made of various parts. So the biggest part of the rocket is filled up with fuel and very, very large engines, bigger than the ones you'd see in a truck or a car or even an aeroplane. Now, once it's got most of the way to space, most of that fuel has been used up, and the big engines are no longer as useful as they were. So if that part of the rocket falls away back down to Earth, then a smaller rocket with smaller engines at the top can carry the astronauts or the satellites and spacecraft to their final destination without using as much fuel because it's much lighter then.
Ah, very interesting. Very good. Right, so we should now have, hopefully, 2, let me turn them around so you can see, 2 little fins. Now, on our fins, we can see there's some dotted lines. We need to fold the paper on those dotted lines because there's no good having flat fins because they're not going to do anything. So we're going to fold them. So you should have 2 folds on each fin.
I went ahead and they look like this.
Yep, very good. I'm just nearly there. Again, it might be easier to do it on a table if you have a table.
Yeah.
Great, so I've got 2 fins now, and now we've got to attach it to our rocket. So to do this, you need some sellotape, and I've grabbed some sellotape that's the length, just a bit longer than the length of your fin, and I'd cut it in half. So let me get my sellotape so I can show you. Ooh, so I've got a piece of sellotape, and I'm literally just gonna cut it up long ways so it's split into 2, so it becomes narrower, so it fits in the gap where we've just folded very carefully. So I've got 2 now pieces of sellotape.
Yeah.
And then where we folded, I can place the sellotape. Oop, dropped it. Place the sellotape in between. And then we have, don't mind, it's gone wrong. Let's do that. So hopefully it will look like that with these folded bits, and then we can get it and stick it on the end. So let's just have 1 fin for now,
Yeah.
and see what happens with the 1 fin.
So I did mine slightly differently. Instead of cutting the sellotape, I rolled it up. I rolled it up, and then to make it like a double-sided sticky tape. So that's another way of doing it.
Yep, there's several ways of doing it. Great.
I think it would be good to mention that when flying these rockets, make sure you do not point at a person or a cat or a dog or anything. Maybe just leave space there.
Yeah, put a target on a wall. If you have like a print out a target and stick it on a door or a wall, that would be good to aim for.
So we're going to have a go with 1 rocket, one rocket. We have got 1 rocket with 1 fin, and see what happens. Right, are we ready? Has everybody go? 3, 2, 1, and go. Oh, it flew, definitely flew. Mine did.
Yep, but
Yeah.
mine it spun.
But mine
Mine's
didn't
gone all the
quite
way
go
over
where
there.
I wanted it to, though.
No, it didn't quite go where I wanted it to, and mine did spin a lot. So I think, do you think we need to add another fin to be able to stabilize it a lot better and balance it
So
out?
I think 1 fin made it spin around. Adding another one would stop it from spinning around, hopefully.
Hopefully, yes.
So let's
I've
add
noticed mine started this way and ended up that way.
yes.
Yes,
So
let's see
let's add
what
our
adding another one does.
fin. Yeah, so we do exactly the same method as we did last time.
So what Vicky and I did was have this sellotape and then just roll it like this. Now you have a circular thingy here, which you just place in here. Now you can stick this to the rocket now.
Right.
Now, where's the best place to put it, do you think? Right next to the other one or directly opposite on the other side?
Oh, good question. So I put mine directly opposite on the other side, so it would balance it out.
Okay, let's give
So
that a
if
go.
it's nice and symmetrical,
Yes.
that's a good idea.
Well, we add a last fin on. The question is, what's your favourite part of your job? Let's go to Vivienne.
Oh, that's for me it's working with high energy lasers. I have an engineering background and I never thought I would work with lasers, but here I am and I'm enjoying working in the lab. So that includes helping out with putting the lenses and mirrors on the table or designing it on the computer first before you put it on the table, because before you try anything you have to test it out somewhere first. So that's my favorite part of my job.
Very good. And Hannah, what's your favourite part of your job?
Mostly all the different spacecraft I get to play around with on a daily basis. I do vibration testing as well, which is where we basically shake a spacecraft component very hard to see if it will survive very strong vibrations that it will feel during a rocket launch as well. So there's all sorts that goes on, and just the range and size of the spacecraft I get to play around with is quite exciting.
Does anything ever actually break in testing?
Oh, yes. I mean, it's all down to engineers working really hard on designing and building things, but occasionally something's bound to go wrong. Sometimes new batteries for spacecraft systems, if they haven't been tested before, anything could happen. So they could explode even. So we have to be very, very careful when we're testing batteries, and things that are very delicate, like mirrors as well. We have had a couple of those that have, the design has led to their breakage, unfortunately.
But
So
that's okay, because we find out, and then we can find out exactly what caused that problem and go and fix it. Yeah.
Exactly.
So you wear some protective gear when you do that, do you?
Yes, we have. Well, if we're testing a new battery or a new cell, we have a huge dome that we place on top of the shaker while the batteries are being tested, in case of any fire or explosion, something like that, to protect the rest of the room, protect the equipment, and protect us as well. Yes, we have to wear safety boots and goggles when we're working in there.
Very cool. Great. Okay, so I think we have our rockets. Shall we do
ready
a blast and see what happens now?
Yes.
With having 2 fins on our rockets. Okay, are we ready? 3, 2, 1, go! Mine doesn't come off.
Mine didn't spin. No.
Yeah.
Oh.
Oh, that was a good one, Hannah.
Thank you. Yes, yeah. I think it's definitely more stable than the last one was. Yes.
Great.
Yes.
So I'm going to go and rescue my rocket.
Yeah.
So there we go. We've all managed to make a rocket and ready for our satellite to go in. Great. So how long do you think it takes to make a rocket? A real rocket, not a paper rocket, real rocket. It must take many, many years, I would have thought, to design. And hundreds of people are needed to be able to create those rockets, all from engineers to scientists to project managers, admin, everyone is needed to be involved. So, one last question for you both. Have you always wanted to pursue a career within STEM?
Ooh. Do you want to go first?
Okay. Yeah, I'll give it a go. I'd say yes, definitely for me. From when I was your age here, I always loved science. Science and maths were my favorite subjects. English, less so, unfortunately. But yes, always science. And as I grew up, seeing space documentaries and space TV programs, and you wonder what's out there a bit more. So always STEM. And for me, space was the way to go.
Great. Very interesting. And Vivienne?
Yeah, for me, it's the same. I always found science very interesting, and also how I could tinker with stuff. That's why I went to engineering. With engineering, you study a lot of physics, which I really love, but I also find it very difficult and very, it just keeps me want to learn more some stuff and keeps you going. So yes, I wouldn't say that I thought I'd be working in a laser facility, but I think that's one of the beauties of working in STEM. It makes you flexible. You can work in different industries or different projects, depending on what you like and what you want to be good at. So
yeah, definitely science subjects that you can do even in school give you those problem solving skills, which really you can do for any type of job in STEM, which I think is great. My role is slightly different. As Kate said, I'm in communications. I'm a science communicator. So I was always interested in space and I did like science, but I actually also really liked languages. So I studied German, French, and Spanish. So I liked talking to lots of people, learning different languages, different cultures. And I found that I could combine both of my passions for languages and science to become a science communicator. So there are lots of jobs related